Hello, welcome to this lecture of this course on computer aided power system analysis. In the last lecture, we have looked into the basic procedure of the Gauss-Seidel Gaussian elimination method. We have also discussed very briefly that how to incorporate this Gaussian elimination method in terms of this matrix operation. So, in this lecture, we would be looking into these matrix operations in details. So, followed by one example, one small example. So, let us start. So, we have what we have is, say again we take an example that A x is equal to b, and we are talking about say A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, and A41, A42, A43, A44 into the unknowns are x1, x2, x3, x4, and on the right hand side you have got b1, b2, b3, b4. So, this is the case. We denoted that this we have got rows, 4 rows R1, row 1, row 2, row 3, row 4, row 4. So, our steps would be that, as we have looked into, that the first step 1 would be step 1, that we say that R1 is equal to R1 by A11. So, essentially you would be dividing this entire row by A11. So, then therefore, what will happen? So, here we will have 1. So, this would be now given to 1. So, then therefore, this would change to 1, this would change to 1, and this would be changed to A12 by A11, this would be A13 by A11, this would be A14 by A11, and this would be B1 by A11. So, let us say that this would be changed to A1 dash, A13 dash, A14 dash, and it would be B1 dash. So, this is after step 1. In step 2, what we do? In step 2, there are 3 parts. Step 2, there are 3 parts actually. Part 1, that we do R2 minus R1 into A21. So, we say that this is, so we say that R2 is equal to R2 minus, so new R2 would be equal to R2 minus R1 into A21. So, what we do is that we do multiply this entire row by A21. So, then here we will get one A21, and then here of course A12 dash into A21, A13 dash into A21, A14 dash into A21, and then here also we will have B1 dash into A21. And when I do subtract this entire new row from this, so it will go to 0. So, it becomes 0, this becomes 0, and it would be A22 minus A1 dash, it would be A22 minus A12 dash into A21, and etcetera, etcetera. So, let us say this one will also be changed to A22 dash, A23 dash, A24 dash, and B2 dash. Then in step, then in the next we would say that R3 is equal to R3 minus R1 into A31, and in the third step we write that R4 is equal to R 4 minus R 1 into A 4 1. So, this we will do. So, once we do this, so by the same logic what we will find that this would be 0, this also would be 0. So, then what we will have here that it would be 0, it will also be turned out to be 0, and all these terms will change A 1 3 2 dash, A 3 3 dash, 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 dash. So, this completes step 2. So, what we have done essentially, we have essentially made all these terms in column 1 0 except this first pivot. Then in step 3 what we do? We do that in step 3, what we do? So, now we work with this new R 2. So, we do that R 2 is equal to R 2 by A 2 2 dash. So, what we do essentially, we actually divide this entire row by A 2 2 dash. So, by doing so, we make this to be 1, make this to be 1, and this becomes A 2 3 dash by A 2 2 dash, this become A 2 4 dash by A 2 2 dash. So, these values would be changed. So, let us say that it becomes A 2 2 double dash, this becomes A 2 4 double dash, and this also becomes B 2 dash by A 2 2 dash. So, let us say that this is becomes B 2 double dash. After that what we do in step 4? In step 4 we have 2 steps. In step 1 we do that R 3. So, now we would be working with this. So, R 3 is equal to R 3 minus R 2 into A 3 2 dash. So, essentially what we are doing now, because we have got one unity here. So, we do multiply this entire row by A 3 2 dash. So, once we multiply this entire row by A 3 2 dash, so then therefore, here we will get one A 3 2 dash, and here of course, A 2 3 double dash into A 3 2 dash, and etcetera etcetera. It will be A 2 4 double dash into A 3 dash, etcetera etcetera. Then when I essentially subtract this new row from this, we get here 1 0, we get here 1 0, and this term becomes A 3 3 dash minus A 2 3 double dash into A 3 2 dash. So, then therefore, this value will also change. So, it will become A 3 3 double dash some value. This will also change from this to A 3 4 double A 3 4 dash minus A 2 4 double dash into A 3 2 dash. So, it will also change to A 3 4 double dash, and this one will also change from B 3 dash to B 3 dash minus B 2 double dash into A 3 2 dash. So, this also becomes B 3 double dash, and here also we then in step 2, in the part 2 of, so please from here this is, so this is part of, and this R 4 is equal to R 4 minus R 2 into A 4 2 dash. So, this also another step we have to do, or rather another part we have to do. So, once we do that, by this same logic, this becomes 0, these values get changed. So, they all become A 3 4 double dash and A 4 4 double dash and B 4 double dash. So, in step 5 what we do is, so step 5 what we do, so now we work with this and we subtract and we simply divide this entire row by A33 double dash. So, then what we do is that R3 we do R3 is by R3 by A33 double dash. So, once we do that, what we get, once we divide everything, so what we get is this becomes 1, so this becomes unity, and this becomes A34 double dash by A33 double dash. So, it is changed. So, let us say that it becomes A34 triple dash, and this becomes B3 double dash by A33 double dash. So, this becomes B3 double dash. And the last stage, step 6, what we do is, step 6, what we do is, we do R4 is equal to R4 minus R3 into A4 3 double dash into A4 3 double dash. So, once we do that, so then what we get, so this becomes again 0, and this becomes, and this also changed because it will be A4 4 double dash minus A3 4 triple dash into A4 3 double dash. So, then therefore, this value will also change. So, it will be also A4 4 triple dash, and it will also change because it will be changed to B4 double dash minus B3 triple dash into A4 3 double dash. So, this will also become B4 triple dash. So, once we do that, so then our final solution would be, so then the final solutions would be, so we start with the bottom one. So, we start with the bottom one. So, x4 would be given by, from here, B4 triple dash by A4 4 triple dash. So, it would be B4 triple dash by A4 4 triple dash. Then what would happen to x3? x3 would be basically, now from this equation, x3 plus A34 triple dash into x4 is equal to B3 triple dash. So, it would be B3 triple dash. So, it will be B3 triple dash minus A34 triple dash A34 triple dash into x4, and x4 would be from here. So, it is minus A34 triple dash into x4. Similarly, x2 would be B2 double dash, B2 double dash, it would be B2 double dash minus A23 double dash into x3 minus A24 double dash into x4. Please look at this equation. So, x2 would be B2 double dash minus this into this minus this into this, and this, all these are known, and x3 x4 we have just now calculated from here. So, it is known, and x1 would be essentially from this equation B1 dash minus A12 dash x2 minus A13 dash x3 minus A14 dash x4. So, that is how it would go. Now, here we have assumed that, well, we did not face any kind of problem of the pivoting. Pivoting means that whenever, that is basically whenever we have tried to divide, for example, here, here and here, right, these values A11, A222 dash and A33 double dash, they are all non-zero. So, here the assumptions we have taken, that assumptions were in our calculation here, that assumptions were that all pivot elements that is A11, A22 dash and A33 double dash are not equal to 0, because if they are 0, so then this divisions do not exist. So, in that case we will not be able to get the modified row. However, if there is any problem that if this quantity, for example, if A22 dash becomes 0 here, for example, after this elimination, so then what we will do? So, we will simply swap this with this, right, and then we will start working with this. So, then therefore, whenever we will face that some pivot element, or let us say 1 or 2 pivot element has become 0, or rather d pivot element which we wish to work on now has become 0, we will simply swap this row with the row just below it. If it is, if the corresponding element in that same column is actually non-zero. So, in that case we will simply make that particular element to be the pivot element and then continue. Now, for this simple 4 cross 4 system, this is pretty simple. Obviously, now we can very easily understand that if we do extend it for any n cross n system, this methodology is extremely just absolutely the same. So, this can be easily extended to any general n cross n matrix relation. Now, let us look at at one very simple example, simple numerical example. So, now let us look at this example, one simple numerical example. So, we have got, again we have taken one 4 cross 4 matrix, and there are 4 unknowns and these are known. So, B1, B2, B3, B4. So, in step 1 what we do now, again this is R1, this is R2, this is R3, this is R4. So, this is R1, again it is R1, this is R2, this is R3, this is R4. So, then in the first case we are dividing R1 by A11. So, that is this as we take a pivot. So, where A11 is 11. So, we are taking this as pivot. So, we are dividing everything. So, when we are dividing everything, we are getting this, everything is changed. So, this was changed. These 3 rows are remaining unchanged. In step 2, I have got 3 parts. First is that R2 minus R1 into A21. So, then therefore, what we do in the first case, that this row minus this row into 23. So, what we will do now? We will now simply multiply this changed first row with basically 23. So, when we multiply this changed first row with 23. So, this element becomes 23 and this becomes something else. So, and when we do subtract them, so then this becomes 0 and these elements change. So, then therefore, these elements change and similarly also this element change. And same what we do is that after that we take this one, that is we multiply this row with 22. So, then therefore, we get 122 here and then we simply subtract this row from this row. So, we get another 0 and these values also get changed, and the last stage we do multiply this row with 12. So, we get a 12 here and then we and also these values changed and then we simply subtract this changed row from this row. So, here we get 1 0 and this values become something else. So, once we get these values, so this is basically after this after step 2. So, in step 3 what we will do is that we will simply divide this entire row, this entire second row by minus 8.5455. So, then when I divide this entire second row by minus 8.5455, what you will get, that I will get simply one unity here, and these values will also change, and that is what we are exactly doing. So, we are dividing this entire second row by minus 8.5455. So, we get some value. So, here you see all these are negative. So, then therefore, when I divide all this negative quantity by another negative quantity, it becomes positive. So, this value changed. And now what we do is, and you see, and these 3 and next 2 are remaining same. So, this row, sorry, so this third row and this fourth row, they remain as such same. Then in step 4, what we do, that we now multiply this row by minus 2 and then subtract the product from this row. So, this becomes 0, and so this becomes something else. So, this becomes 0 and this element changes, this element changes, and this element also changes. Please note that because this is 10 and this is minus 2, so then obviously this will be more than 10. Similarly, we do now multiply this row by minus 3.5455 here. So, then here we will also get one minus 3.5455. So, once we get this minus 3.5455, then what will happen? So, then after that we will simply subtract this row from this row, so we will get another 0. Then this value changes, this value changes, and this value also changes. So, you see after these 2 steps we get these 2 and these 2 to be unity, and all these rows, all these elements to be 0. So, in the last 2 stage, in the next stage what we will do, we will simply divide this entire row by 0.9574. So, once we divide this entire row by 0.9574, we get one unity and we get something here, we get something here. So, we get unity, something here, something here, because we are 5.27 by 0.9574. So, it will be more than 5.27. So, we get some value, so we get also some value, and then after that we simply multiply this row by 26.6065 and then subtract the resulting row from this row. So, we get here 0, right, and then we get here something. So, it will be almost minus 130 or something. So, we get something, and then we get also here something. So, now what we have got? So, now after that our final solution would be x 4 would be this divided by this. So, the final solution x 4 would be this divided by this, all are minus. So, then this minus has been omitted. X 3 would be this minus 5.5114 into x 4. So, it is exactly 10.6672 minus 5.511 into x 4, x 4 is this, and x 2 would be 0.107 and x 2 would be 0.1064 minus this into this minus this into this. So, now here what happens, that because this is negative, so it is 0.1074 minus 1.4787 minus 1.4787 into x 3. Now, x 3 is actually minus 0.4735. So, then it is minus into minus. So, minus of minus, it becomes plus. So, it is 1.4787 into 0.4735 minus 0.6383 minus 0.6383 into x 4, and x 4 is 2.0214. So, when I plug this and do this calculation, we get minus 0.4837, and x 1 would be that 0.9091 minus this into x 2 minus 1 point this into x 3 minus this into x 4. So, because x 2 also now negative, so this becomes plus, x 3 is also negative, so this becomes plus, but x 4 is positive, so this becomes minus. So, once we do this calculation, we get this value. So, these are the final solution. So, then by this method one can easily solve the any set of n cross n matrices, or rather any set of n cross n linear equations involving n unknowns. One condition here should be that this n linear equations involving n unknowns should be independent in nature. That is, if they are not independent in nature, so then therefore, this resulting matrix A matrix would be basically a singular matrix. So, then therefore, if the singular matrix, so then so then therefore, even if we do carry on this Gaussian elimination method on the singular matrix, ultimately at some point of time we will face trouble and will not be able to calculate the final answers. So, then therefore, one has to be very sure, or rather one has to be very careful that these equations which we are taking, those equations are independent in nature. So, that this resulting coefficient matrix, that is matrix A, is actually non-singular in nature. Although this Gaussian elimination method has got some I mean it is a very simple method, and also it is very easy to code, but then it has got some basic problem. Now, let us look at some problems of Gaussian elimination. So, there is some limitation in Gaussian elimination method, and these limitations are basically nothing but this fill in problem, and this fill in problems is nothing but that when we are trying to do Gaussian elimination method, and if this original A matrix, if there are some 0 values in the process of Gaussian elimination method, those 0 values becomes ultimately non-zero. So, then if these values become non-zero, so then therefore, we are not really being able to exploit the advantage of sparsity, right. So, then therefore, we need to little more careful in carrying out these operations of this Gaussian elimination method. So, this aspect we will continue in the next lecture. Thank you.